Welcome back to another episode of the Heatio Home Energy Show, where today we're joined by Ethan Wadsworth of Discrete Heat, Sales and Marketing Director of Discrete Heat. So thank you very much for joining us today, Ethan.
Thanks very much for having me.
And today we're going to be talking about all things ThermaSkirt.
Yeah, skirting board heating. Let's say all things emitters.
All things emitters and the benefits, I guess, of skirting board heating over more traditional forms of heating in terms of radiators or blown air.
Yeah.
Do you want to start off by just giving us a little bit of background to who you are and what got you into the world of discrete heat?
Nepotism is basically it. So it's a family business. Martin, who's my father, he's actually the inventor of the product.
Wow. Okay.
As a bit of a background to sort of us as a family, we've sort of always worked for our dads, going back sort of generations, but every generation's done something different. So my granddad worked with my great granddad as an engineer and worked as a draftsman. He started a business in the 70s, an engineering business that went on to become a safety switch business, and very similar kind of plots to the previous business, which was EJA Engineering and Discrete Heat. But EJA Engineering was a very innovative company that existed for many years until the legislation changed, and the legislation changed in the favour of health and safety, and that massively drove up demand for safety switches and electronical safety equipment, and obviously that lifted the business. And a very similar story to us, Discrete Heat was formed in 2007, basically after Martin and my granddad Tony sold out EJA. Martin went into property development, and while he was building property, he had this issue with radiators and where to position radiators, and a lot of the projects that he was doing were retrofit applications, so underfloor heating wasn't an option. He built his own house at the same time and fitted underfloor heating in there, which is great on the ground floor. Having lived in that house, I can tell you from experience, great on the ground floor, but where we had oak floors or carpets in the bedrooms, it was compromised, definitely. It was too hot, too cold, very difficult to control. And through that experience, when he was talking to his plumber, he said, I really need somewhere to put these radiators and so on. And his plumber said, why don't you try skirting board heating? Coming from an engineering background, he was like, make a piece of skirting board out of aluminium, put two pipes behind it, flow and return, heat the aluminium up, massive radiator, genius, go and get me a piece. And what the plumber brought back was the stuff that, I don't know if you remember it from like the 60s and 70s, it was like 3 inches thick, a big grill on the top, a 28mm copper pipe with aluminium fins on it. Yeah. And basically my dad was like,
I'm not putting that in my house.
I'm not putting that in, there's got to be a better way. So being from a manufacturing background, he had like this itch to get back into manufacturing, and he researched the product and he couldn't work out, why has nobody made this? Is there some sort of fundamental reason why this hasn't been done? And sort of found a genuine little niche in the market. And it was kind of in that sweet spot where a product like ThermaSkirt wouldn't have worked very well in the 70s and 80s because U values were not where they are now. Even if you take a Victorian terraced house today with loft insulation and double glazing, it's more thermally efficient than a brand new build in 1975 because that makes such huge difference. So we were kind of at that sweet spot, early 2000s, where the legislation wasn't quite changing. Energy efficiency was a phrase, but not a buzzword, that's for sure. And so people weren't really thinking, how do we do heating at that time? And so at that moment, off he goes. And basically what I watched my dad do was take a tremendous risk in basically tooling up and trialing a product. And I remember going with him to install the prototype. So he had a house that he was renovating, and we went to install the prototype in the house, and it worked. And it was hot. Yeah. We just had an aluminium profile with 2 connectors, and they were held together in the corners with John Guest fittings, and it worked. The house was warm. Fundamentally, the test data at that point was relevant. You put hot water in it, the room got warm.
Yeah.
So fundamentally, we knew we were on something. And then then you have to put £500,000 into tooling and patents and trademarks. And the amount of times, we've been in the pub or whatever, and somebody goes, "Oh yeah, ThermaSkirt. I had that idea 20 years ago." Yeah, you might have done, but you didn't actually do it. And that's the difference, is that you've got to have the rare combination that my dad's got, which is this need for challenge, this like motivation and this drive, but also, for want of a better phrase, he's got the balls to go and do it and take a risk. And it's been really, really, really difficult because, previously he worked in oil and gas. So any innovation in safety switches was instantly adopted because it was needed. And I think he kind of got accustomed to the fact that if you've got a genuinely innovative product, the market is going to hoover it up. And as we know, and as we're probably going to discuss today, the construction industry in the UK is not necessarily
definitely not
the first to innovate.
That must have been a horrible feeling when he's walked into this and started having plumbers turning around to him going, "No, I'll just carry on fitting."
It was a baptism of fire from a sales and marketing perspective. I'll put it that way. Basically, when I joined the business, there was about 7 people in the company. There's 30 of us now and growing. But he basically gave me a sample case and a set of car keys and said, "I do not want to see your face at the office. Go away." That was it. Just disappear. And because we'd just been on Dragon's Den, we got picked up by Plumbase. And at the time, they had these things called innovation evenings. And what the innovation evening was it was a pseudonym for, a booze up, basically. So they'd invite down like 10 manufacturers. So they'd be like us, Polypipe would be there, Valent, all the usual suspects, Fernox and what have you. And they'd do these regional events. They'd invite all the local trades down, their accounts, free bar, buffet, presentation by the reps.
Yeah.
And, you go around the reps and they're like 60, in their 50s, in their 40s. And there's me and I'm like 18. I've had my driving license. Yeah. I've had my driving license for 6 months. And, I looked about 12. I look back at pictures of me when I'm 18 and I'm like, oh my God, you can imagine the abuse I'd got because we had no money. So Plumbase, we had no marketing budget. So Plumbase very kindly let us do the innovation evenings for free, whereas the other manufacturers were paying a lot. And the caveat to that was we had to go on last. So by the time I got up there to do my bit, most people were bladdered. Yeah. And that was it. So I used to just get dog's abuse. It was a product that was so new, so innovative. And the market, I think the plumbers just saw it as unnecessary. They had heating wrapped up, boilers and rads.
Straightforward. Everyone knows what they're doing.
Yeah. Even in 2010, 11, there was plumbers there who were saying underfloor heating doesn't work and stuff. So
I think, coming from a plumbing background, I think I can honestly say we're probably one of the most skeptical trades. You see what's in front of you, it works. You can get your hands on it. You know what you're doing with it. But for the viewers that don't necessarily know what skirting board heating is or ThermaSkirt is, what are we talking about as this product? What does it look like? What can it do?
So it looks fundamentally just like a skirting board. And I think that's probably one of the reasons why people have been so skeptical of it, because normally when something looks big and clunky and industrial, they're like, wow, that's gonna work. It does look very elegant. So it's only 20 millimeters thick. We manufacture it in profiles that are based on existing skirting profiles. So it is identical. But what it is a giant aluminium panel, and it gets hot all the way around. And obviously that heats your room. So from a surface area perspective, I think people look at it and they think, well, there's no way you can get as much surface area on that as you could from a radiator. The easiest analogy I can think of is if you imagine taking all the skirting boards out of your room. So imagine this room we're in now. You take all the skirting boards off and chop them into 1.2 meter lengths and stack them up. How high would that stack of skirting boards be? It would be the size of a radiator. And nobody sort of questions whether a radiator would work or not. What ThermaSkirt fundamentally is it's a heat emitter option. So from all the options that we have when it comes to renovating a house or building a home, heat emitters is probably one of the most sparse or scarce options in terms of range, radiators or underfloor heating. This is on a wet heating system, obviously. We offer that third option. So what ThermaSkirt fundamentally does is it rolls some of the advantages of underfloor heating. So even heat distribution, works well at low temperature, frees up all of your wall space, very hygienic. It also rolls some of the benefits of radiators in, so simple to plumb. It's a standard flow and return connection. You don't need any manifolds, you don't need any controls. It's just a radiator. Easy to retrofit, so you can take your skirting boards off and you can connect onto existing radiator pipes, and simple to operate. So it's kind of got the simplicity of a radiator, but with the performance of underfloor heating.
So you would, you would take, if you took an existing radiator off the wall, you were literally plumbing into the same flow and return that's already gone into that room.
Correct. Yeah.
Okay.
Yeah. So to all intents and purposes, it's a designer radiator. What's changed is the electrification of heat. The movement towards heat pumps has meant that the designer radiator market is really struggling to adapt to that low flow temperature. So, generally beautiful looking radiators, I'll put beautiful in inverted commas, but, not ugly radiators generally have a lower performance. So when you turn the flow temperature from 70 to 40, that performance really is compromised.
I know. Are we struggling with the same issues that a lot of retrofit applications have when it comes to fitted heat pumps? That you're still in this situation where if you've got small diameter pipework, micro bore, and 10 mil feeds, do they work any better with your systems than they would with a radiator?
Yeah. So. No is the short answer. Your pipe diameter at a certain delta T will deliver X number of watts.
And delta T, that's about this. We're talking about this, the temperature that you're putting in, regardless.
Yeah. Sorry.
No. It's good. It's so that when we're in this, when we're doing these kind of calculations to work out how much heat you need in a room.
Yeah.
There is a bit of an industry myth that if you've got microbore, it simply won't work with a heat pump, and from my experience, what we're saying is actually it's based on the room. Some rooms can take it depending on the temperature that you're looking to put into it.
Yeah, so it's a heat loss question.
Yeah.
So for the uninitiated, a 10 mil pipe can deliver a certain amount of heat at 70 degree with 70 degree water, and a 10 mil pipe can deliver less heat with 40 degree water. Same as a 15 mil. Mm-hmm. But 15 mil at 70 degrees is probably oversized for most radiators. So it's ideal for heat pumps. But you're right, there is this myth that you can't do 10 mil on heat pumps. You can do 10 mil on heat pumps so long as the heat losses are low enough for that 10 mil to be able to deliver that heat. That's the same for ThermaSkirt. What the difference is with ThermaSkirt is that if you think about where radiators are located, generally a radiator is located underneath the window, an external wall. So typically radiators are located, the pipework connects into the radiator at the extremity of the room. So a typical house that's on 10 mil, if there's any plumbers watching, you'll know exactly what I'm talking about. You take a few floorboards up on the landing, there's your 22 mil pipe with like this spider's web of 10 or 8 mil microbore flying off it in all different directions. If you need to replace that with 50 mil to install a heat pump, you now have to get fresh feeds from the center of the house to the extremities of the house, which can involve a huge amount of disturbance. So taking up floorboards, moving furniture out, lifting floor coverings, because you have to get to the radiator position. What we do with the ThermaSkirt is we start it just at the inside of the door. So you basically come off that 22 on the landing and go straight to the inside of the room. And that's where the ThermaSkirt starts.
So you're kind of starting inside that doorway, if you like.
So you're minimizing disturbance because you're containing the area of disruption.
And that is your flow and return point there? You're not having to run around the room and then get your return out or anything like that?
No.
You're doing it all from that same point.
So one of the smart things about the system is that the end of the run, as far as the water's concerned, is the halfway point. So if you imagine you've got a 40 flow and 35 return, where the water enters the skirting, you've got 40 and 35, so 37.5 degree mean. At the end of the run is the halfway point, so it's 37.5 and 37.5.
So it's blending it all the way around.
So it's mean. So the mean temperature is the same. So people ask us, well, how long can you do before it runs out of steam? Well, it doesn't run out of steam because the end point's the halfway point. So it's always going to be in equilibrium. You have to just measure your flow and return, which is one of the reasons why ThermaSkirt works so well on open loop systems. Because really, people talk about more control, but on a heat pump, actually, you want less individual control. You want to size the emitter according to the losses and run it.
Yeah.
Just let the heat pump run. Like when Graham was on the podcast, he talked about you plug your fridge in and it just runs there all day and you don't think about turning it up and turning it down. Yeah. And that's exactly what the heat pump should be doing, just running when it's needed.
And that's what you're creating with these. Are you creating more open circuit then for the system? We know heat pumps like to just kind of whirl away and do their job. And we actually did an installation not so long ago where the customer wanted, they've got Nest controls throughout the property. They got multiple zones, and
they like playing with them probably.
Yeah, and they were absolutely adamant. We talked to them about the benefits of controls. Now I know some engineers would have walked away from this job and said, if you don't follow my specification of how installation should be done, then I will go and find another customer who will. But we were like
the militant heat pump installer.
Exactly, yeah, the purist. Whereas we were confident enough that this customer would change their mind when they seen the data post installation. So it went in and they had a Nest thermostat on the first floor and second floor, and then underfloor heating on the ground floor with the individual zone control. And you can clearly see from the data that the heat pump is firing up, going off, firing up, going off, firing up, going off. Yeah. In comparison, we shown a comparison to a system that was just running purely on weather compensation, and it's way outperforming the other system. Yeah. There. So we know heat pumps work better when they just get to whirl away and do their own thing. I would imagine the greater the system volume, the more water we have in this system, the more beneficial it will be for the heat pump. So are we getting that in comparison to, say, a radiator system with ThermaSkirt? Are we getting more litres of water in the system?
The ThermaSkirt has got the pipes inside ThermaSkirt are oval. So when you look at it, it's a very, very narrow profile, but you actually get a very high volume of water through those pipes because of the ovality of the pipe. It's the equivalent of an 18 mil ID pipe. So you can get a very fast flow rate through the skirting, which means you can keep the delta T very, very low across the flow and return. So once the room comes up to temperature, you can work to like a delta T of 5 on your flow and return or even lower. We're doing some trials at the moment in Energy House 2 at Salford University. And really one of the tests that's being performed is how low a delta T between the flow and return can we get. Mm-hmm. 5's obviously ideal. But if you can get like a delta T of 5, like a flow of 40 and a return of 35, when it's minus 10 outside, then we're laughing.
Yeah.
Because, I'm a very strong believer that your heating system should not be something that you have to think about as a homeowner. You should not have to think about your heating. If you're coming home from work and going, I better turn the heating on, it's designed wrong or it's being controlled wrong. And that does require like a flip in people's heads, and people think, for example, when someone says, oh, well, when I leave work, I can go on the app and flick the heating on. Don't do that.
No.
You wouldn't say, oh, I'm coming home from work, so I'm going to flip the fridge on. So my beers are nice and cold when I get back.
It's the same logic, honestly. And I want to go back to your point on the delta T, and for anybody watching, the delta T is the difference between the flow temperature and the return temperature.
Yeah, delta T. Delta is just it's a Greek letter that just signifies difference, and T is temperature, so it's just differential in temperature.
Difference in those two temperatures.
Yeah, and there's also something that people often miss. I find from our work with homeowners is they hear two different references to delta T. So you've got delta T, which is your flow and return temperature. That's the water out of the boiler and water back to the boiler or heat pump. And then you've got delta T to the room. So radiator outputs are listed at delta T 50. That's not a 50-degree difference between the flow and return. It's a 50-degree difference between the target room temperature and the emitter temperature.
And the reality is for most consumers, they're going to be like, just
stop talking.
They're like, I don't really care about that stuff. Just tell me the thing's going to work. But from a heat pump perspective, this is quite important because as you say maybe from in comparison to a radiator circuit, you're saying that so the delta T is not as critical with the difference between the flow and return temperature is not as critical with a ThermaSkirt, but still at the heat pump you're going to want that differential in the temperature. You need that over your heat exchanger to make sure the thing's working.
Correct, yeah.
So are you still achieving a kind of 10-15 degree differential across those flow and returns? What are you aiming for with that?
Well, generally, dependent on what the installer wants, they can adjust the flow rate accordingly because all you do is you just reduce the flow through the skirting, and obviously more heat will be extracted from the water as it flows through the skirting more slowly. And are
you doing that on like with the radiators? You would balance the system. Are you balancing it in the room, or is it balanced at the point where the pump is firing this stuff around the system? There's
two ways of doing it again. So you can plumb the ThermaSkirt just like a rad. So on a standard distribution system, you've got your primary flow and returns branching off in 50 mil or 10 mil. Or you can plumb it like underfloor heating where it all goes back to a central manifold.
And you can balance it.
And you can balance it locally at the manifold. You know, there's companies like Salus who do the automatically adjusting thermic heads for manifolds. So they have a pipe, they have a sensor clip. So the clips go onto your flow and return at the manifold, and then they automatically balance based on the flow and return that you set it. So it's quite clever. So what it does is it senses, if it senses, say, water above 55 degrees, it works on the basis that it's a boiler. So it works to a delta T of 10 or 15. And if it's sensing water below 50 degrees, it says, well, this is on a heat pump. So then it works to a delta T of like 5 or 7.5.
So I would imagine where the mass opportunity for this product is that I'm sure it'll be crazy for new build homes not to pick this up.
Yeah.
Whether there's an argument that, as you say, in a ground floor application where you've got a solid concrete floor, maybe you would go down the route of underfloor heating, possibly, creating that thermal mass and building that up in the floor. Yeah. But as you say, I started off my life doing heat pump installations purely on underfloor heating.
Yeah.
And when I look back now and think of how we were installing underfloor heating in bedroom applications and the kind of house that you ended up living in, it's, as you say, the level of control, the speed of that reaction from the floor, it wasn't the most comfortable for customers in those places.
But you're right.
Your product can alleviate that in bedroom applications.
Totally, yeah. So there's two sort of critical areas to consider here. Obviously, until fairly recently, sort of last 5 years or so, we have pretty much appealed to somebody who doesn't want radiators, purely for aesthetic reasons. It might be thermal comfort reasons. You know, we want something that feels like underfloor heating, but it isn't underfloor heating because we can't have it. You know, there's no surprises considering 70% of the work we've done to date has been retrofit. And that's mainly homeowners going, I don't want radiators in my house. How do I do this? You know, and then off we go. What's happening now, like you say, is on the new build side, it's all set out at low flow temperatures. And now the house builders are starting to strategize how we're going to do that. One of the things that's becoming quite clear is that a number of house builders are doing underfloor heating on the ground floor and ThermaSkirt upstairs. So ThermaSkirt in that case is acting as a first floor solution. It was quite a surprise to me a few years ago to learn that 80% of underfloor heating systems that get sold are ground floor only. And there's a huge number of underfloor heating companies out there that sell underfloor heating and only ever walk away with the ground floor sale.
Yeah.
And up until fairly recently, they've kind of seen us as competition. And it's not competition. Right? There's so much space in the market for heat emitters. There is no competition. So if a customer comes to us and says, I'm doing a brand new build, I want underfloor heating downstairs, and I want ThermaSkirt upstairs, there is absolutely no way on planet Earth we will say to them, don't do that, and try and talk them out of underfloor heating. That would just be completely crazy. That's a perfect solution. Underfloor heating downstairs, ThermaSkirt upstairs. You've got the thermal mass of the ground floor creating a baseline temperature that will work very well on a heat pump running consistently. And then you have the upstairs, which could be a little bit more responsive, responds to the needs of the occupant. It could be off all day and on in the afternoon. That makes total sense. The main thing is moving away from radiators. Fundamentally, the way ThermaSkirt works is very different to radiators. The way it heats the room is very different to radiators. It's a radiant heating system. It's low level. It's spread out around the whole room. Radiators are a single point emitter, so they emit their heat from one location. Radiators rely on creating convection currents. So anything that's hot radiates, convects, and conducts heat. So people, for example, say, oh, it's an infrared it's an infrared heating system, or it's a convection heating system. In reality, it's all three. A radiator doesn't conduct a lot of heat because it's not touching anything. It's touching the radiator brackets, and that's it. ThermaSkirt is a radiant heating system primarily. You're going to get some convection off it, but it's primarily a radiant heating system. Underfloor heating is a radiant heating system. Again, you're going to get some convection off it. It changes depending on the floor covering. You'll get more convection off tiles than you would from carpet. And radiators are convectors, even though they're called radiators. They are convectors. To create powerful convection currents, you need a high delta T. So a hot radiator, basically. The hotter the radiator, the more powerful the convection currents are, the better that radiator is at spreading its heat from a single location. When you lower the temperature of your radiators, the convection currents become weaker. And that's why you tend to need such a large rad.
Yeah.
So the issue that we're coming across now, and it's actually a fairly recent one, since a lot of heat pump legislation is driving installation of heat pumps, is that on paper, this room needs 500 watts. This radiator will give us 500 watts. Therefore, let's put this 500 watt radiator in. Now, given long enough, that radiator will heat that room, obviously. The room has a 500 watt heat loss. The radiator puts 500 watts out. Eventually, that room will get warm. What they're finding is that it's not heating that room up in a time that's convenient to the customer. So
and probably an element of the losses, I guess, in that room as well. If it needs that, but it's losing at an equivalent or greater rate, then I guess it will never get there. It's very slow or very stagnant. And then the moment you change that, like open a window, and you completely change the heat loss profile of that room, it can't overcome it. So you'll find that installers will be getting complaints from customers who say their room's not warm enough, or the other one is the radiator's not warm enough. So they're so used to the radiator being 70 degrees that they put the hand on a 40-degree radiator and go, it's not working. Yeah. It is working. You need to give it longer to heat up. The ThermaSkirt heats all the way around the room. So you are not reliant on it filling the room with heat from one point. People get heating systems back to front. So they think that their heating system heats them up. And that's not the way it works, because, you are 36 degrees, I'm 36 degrees. If we had a thermal imaging camera on us right now, you'd see in this room, we'd be glowing. If this room's 20 degrees and I'm 35 degrees or 36 degrees, I'm heating the room, not the other way around. Okay, I'm losing heat. If I was gaining heat, so if this room was 38, we'd basically be sat here in our underpants sweating. Human beings need to lose heat. What dictates thermal comfort is the rate at which we lose that heat. Yeah. So if we lose heat too slowly, we feel hot and stuffy, and you start sweating. You try to increase your rate of heat loss. If we lose heat too quickly, we feel cold, and you want to put a jacket on or turn the heating up, or whatever. What your heating system is doing is it's mitigating the heat loss of the building. So the better your fabric, ultimately, the less heat requirement you have. Yep. The less of a shortfall that heating system has to make up. So Victorian property, passive house. Victorian property needs 15 kilowatts, and a passive house needs 1500 watts. That's only because of heat loss. All the heating system doing is offsetting those losses. What the ThermaSkirt does is it offsets those losses where they're most present. So we start off with the external walls, and then we go onto the adjacent walls, and we basically offset the loss. So as heat leaves the room,
the ThermaSkirt effectively creates like a heated envelope around the perimeter. And we have, heated threshold plates that sit in front of patio doors and bifold doors. Because again, that's the area of greatest heat loss. So it's not about heating you up. It's about making the room comfortable.
Yeah.
If you lose heat to the room at a steady state, you'll feel comfortable. We have to achieve thermal comfort and not just, raw kilowatts. It's like horsepower. You look at the horsepower of an F1 car and the horsepower of a muscle car. An F1 car is going to win the race, but it might have half the horsepower. It's not just about raw power. It's the delivery system. It's how is that being delivered to the room.
Yeah, I think so. I'm gonna fire a few questions at you that have.
Yeah, sure.
I always find my older brother is a good sense point for this kind of stuff. Not because he's got any kind of engineering knowledge whatsoever.
Yeah.
But I would definitely put him in the category of the average consumer.
Yeah.
So I had the joy of spending a few hours with him whilst we got bored watching the Liverpool United game on Sunday. So that game was as a
dull.
We as a big Liverpool fans, it was that dull that we decided to start talking about what alternative ways of heating his new house he has, and we got onto the subject of ThermaSkirt. So his quick fire questions for you to see.
Yeah, go on, bring it on.
So his first one, he's got a 2-year-old, and one of his concerns would be how hot is it? The little kid, he's going over to it, putting the hand on it.
Yeah.
So is there any chance of it puts the hand on it, it's going to burn the kid's hand or anything like that?
Yeah. Okay. So obviously on a heat pump, no, because it's not going to be any hotter than 45 degrees anyway. On a boiler, yeah, the skirting does get hot as a radiator. No hotter than a radiator.
No hotter than a radiator. Okay.
I've got young kids myself, a 3-year-old, a 1-year-old. They live in the house with it. It's winter. It's on now. They're near it. They can feel the heat, but it's nowhere near hot enough to burn them. One of the big features. This is going to sound. This is going into full sales mode here, but this now you know how I've been doing it too long. 87% of radiator-related injuries are impact injuries. So it's kids like running into them and like falling onto them, and I've been there. Kids climbing up the rads or whatever. And then the burns that people may get with the radiators are generally grab injuries. So people, a lot of the time, it's people reaching out for them to steady themselves or what have you, and they grab the radiator, and that leads to a burn.
I mean, I suppose I think the question was probably more born out of if you think all of a sudden I've gone to this really, really small heat emitter in comparison to, say, a radiator that I've had in the house before, then you think, okay, you're going to have to be putting some blistering heat through that to make it warm enough.
Yeah, absolutely not.
But so temperature-wise, we're talking no different to that of a radiator system, a traditional radiator system.
Normally lower. So generally, what happens is now when we're retrofitting ThermaSkirt, a bit like I've done in my house, is when we size the system, even though it's on a gas boiler, if the heat pump mafia on LinkedIn want to come after me now, that's fine. But I've still got a gas boiler, and when we size the ThermaSkirt system, we size it to run at 50. So there's no point in retrofitting ThermaSkirt to a house on a boiler at 70 degrees because you're not gaining anything. You're gaining space and it's more comfortable, but you're not gaining any raw energy benefits. If you size the ThermaSkirt to run at 50 and turn your boiler down, it's always going to be lower. Yeah. One of the things that we're doing at the moment with a number of social housing providers is we're actually doing the ThermaSkirt as like a stepping stone to renewables. So it's like a lily pad, or effectively what they're doing is they're leaving the boiler in, retrofitting ThermaSkirt instead of the radiators, but sizing it to 50 or below.
Yeah.
Turning the boiler down, leaving it for a year, and then going back and saying, were you cold? No. Well, the boiler's running at 50, and then
staging it through. So because you say the obvious thing is, when people touch the radiators and they're warm, if all of a sudden the radiators are cool, and they don't feel like that maybe the room is the right temperature, it's 21 degrees, it's what they want, but actually just feel like it's the wrong temperature. So, okay, so we're saying certainly it's not going to go and we're not going to start pumping red hot lava through the rads.
The short answer to the question is it's definitely safer than a radiator.
Yeah. Okay.
But, I don't really like to slur rads because you end up just getting accused of like shilling a product.
You're not slurring them. The key part here is, my brother's always a good soundboard for this kind of stuff because, these are the kind of questions that your average, man
in the street will ask. Yeah.
Because logic would suggest if you're going to start doing this, you're going to have to put really hot water through it to get it anywhere close to where it needs to be.
It's definitely the opposite of that. Yeah.
And then the other thing that came up is he's not in a particularly old house, but he as with most older buildings, you can get walls that are a little bit aren't quite perfectly square, rooms that aren't perfectly square. In fact, I think if you watch some of the stuff on TikTok with these surveyors that go into these houses now and. You wouldn't say half the new builds are square. So what does that look like? I'm looking down a landing and I've got ThermaSkirt on it. Am I like starting off with a, tight up against the wall and then I've got a 20 mil gap at the other side? How does it cope with your wavy walls that you might get?
Great question, actually. And one, like you said, it's a very, very common question. It's my house. Nothing square in my house. There's nothing straight in my house. Our whole business started off in retrofit. So we had to overcome all of these things. And I suppose if you looked at Mark 1 ThermaSkirt, it wasn't quite ready for that. And the way we've developed the product since has been, it's all been designed to help the skirting flex. So it's made out of aluminium, which over a 6-inch piece, it's pretty rigid, but over a 4-meter wall, it's quite flexible, like a normal skirting board would. And then on the top edge, we have a seal. So like a bit like a window gasket. Effectively, so you slide the gasket in and it creates this neat edge on the top, so it looks like a finished product. It's not manually siliconed in because it wouldn't allow for expansion and contraction in the length, so it basically takes up any undulation in the wall. So some of the projects that we've been doing, they're in like 500-year-old houses, the walls are like a dog's back leg, and we basically bend it to suit. So if you've got very extreme circumstances, we've got a video online actually of us bending the skirting. So this is not an official instruction, but you can basically put the skirting across like 2 toolboxes and literally bend it.
Just flex it in.
Yeah. So
like you would with a skirting board if you needed to, needed to get a little bit of.
Yeah. So it's very robust. It won't like kink or break. But it will flex the wall. If you've got a very extreme situation, you can physically bend it to suit. But to be honest with you, we find that in the majority of properties, it will follow the wall naturally. The brackets that it mounts onto pull it in at those points. So as you push it onto the brackets, it's got a single location and it clicks into place and that will hold it back to the wall basically. So
excellent. And one final one. So I think the one time he did this, so he got onto talking about bleeding radiators.
Yeah.
And the one time he did bleed a radiator, I think he called me 10 minutes later to tell me. First of all, he actually, the first time he phoned me, he had his head underneath a gas boiler trying to figure out how to bleed the radiators. That wasn't a great start. And it was even worse to start when he said he couldn't see what he was doing, so he got his lighter and he lit it.
You kidding me? Under a gas boiler?
Yeah, terrifying. This is probably going to put him in the category of definitely not the average person, because I would hope the average person wouldn't do that.
And I hope he doesn't watch this as well. He's getting a right going over today. But he's aware that sometimes he gets air in the radiators, and he said, well, how would you bleed the radiators? Or how would you bleed? Do you need to bleed the air out of ThermaSkirt? Only on commissioning. So when you commission it, obviously, when you fit a system, it's full of air because there's no water in it at all. There's a bleed screw. So at the end of every single run, there's like a bleed point and a drain valve. So when you're commissioning, what you do is you open up the bleed screw like you would in a rad, and then you fill it up with water. Normally you fill it up from the return, because what that does is it introduces water to the bottom pipe of the skirting, which pushes all the air into the top pipe. And then as you bleed it from the end, the majority of the air comes out. On ongoing maintenance, there is no need to bleed it because it's a horizontal pipe. So radiators collect air because they are like a body of water. So naturally, when you commission a new heating system, you basically release nitrogen from the water and it percolates out. So air naturally percolates out of fresh water. Those micro bubbles, as they pass through the valve, they rise to the top of a radiator and they collect. So you bleed it and you bleed it. With ThermaSkirt, like underfloor heating, once it's been filled, that's it. There's no way for air to collect in it because those micro bubbles, and they are tiny, they get pushed along the pipe. So eventually they either work their way back to, say, a towel rail in the bathroom, so they'd be bled out from the rad, or they'll be pushed back to the boiler or the heat pump, and there's normally an auto vent on the system and the air just leaves the system there. So yes, you bleed the air out of it on commissioning, but there's no ongoing maintenance. So to put that in perspective, I fitted ThermaSkirt in my house we did our renovation in 2018. So I think I probably finished it in 2019. I haven't touched the skirting since then. That's for 4 years. It's not.
Just once.
Yeah. So that's one of the reasons why social housing are really picking it up, because I think 70% of unscheduled maintenance call outs are air in the system.
Well, yeah. And you also get I always think I was told it was one of the biggest successful marketing campaigns that was ever ran by a new entrant boiler service company, where they went to an agency and asked them, how do we get people to take on our service stuff? And the research shown that one of the most searched products on eBay was a radiator bleed key.
Right.
So they put the bleed key on. They printed a load of these bleed keys up with the company's details.
Yeah, branded.
And sold them on eBay for a penny, because logically what was happening was somebody goes to bleed the radiator, pressure drops out the system. The user obviously doesn't know, the homeowner doesn't know what then to do.
There's a number on
there's a number of callers if your boiler's not working. So, no more customers going and bleeding their own radiators and then leading to low pressure faults and call outs.
Correct. Yeah, correct. So in terms of the consumer, because I'm obviously quite conscious of the fact that when it comes to heating, and now particularly with like move towards heat pumps, I do get this real sense like, as an industry, we've sort of made a rod for our own back because we've made it so complicated. In the effort to explain to consumers how heat pumps work, we've like over-explained it, and we've raised more questions than we've answered, because and we've done it now. You naturally slip into this. Let's start talking about delta T's and flow returns, and the homeowner doesn't care. It's like, is it going to work? Will this work? And like you say, you don't go to Curry's and say, explain to me how this fridge works.
And it's just a case of
plug it in, and right.
And if it doesn't work, if it doesn't work, you'll be taking it back and expecting a refund. So it's
exactly that. Yeah. And I think that one of the major things that I've come to realize is that the problem, heat pump manufacturers, many of them, are still fighting this battle that's already finished.
Yeah.
Like the analogy I use is like, those Japanese soldiers who were sort of found on the island, they're still fighting the war 30 years after it ended. That's kind of like what I think some heat pump manufacturers are doing. They're still shouting that heat pumps work, heat pumps work, heat pumps work, because obviously you get articles in the Telegraph that tell you the opposite. But in reality, it's not the fact that people don't think heat pumps work, it's that they're concerned about the disturbance to their property and the compromises that they might have to make to their lifestyle.
Yeah, and unfortunately, there's a lot of installers out there that are also advocate for huge amounts of retrofit work that and won't necessarily touch a heat pump system unless those level of upgrades are made, which also alienates a lot of consumers from making some of those.
Yeah, you did like a fabric
choices.
Fifth.
Yes.
Thing the other day, didn't you? On Mesh Energy, yeah.
Yeah, and talking about how and again, the point of that wasn't to say don't make building fabric upgrades, but if we're going to start to really turn the turn the screw on decarbonisation of our heating systems, you know, we need to take an honest and hard look at the fact that there's 1.7 million boilers going in every year. 50% of those are going in a distress purchase situation.
Yes, yeah.
And in a distress purchase situation, people are not going to sit around and wait for, no disrespect to ThermaSkirt, but
absolutely.
You know, they want they need a solution that is going to go in, it's going to work, it's going to be cost effective, and all the bells and whistles that get wrapped around some of this stuff. But we are gonna touch on a bit of that in the next episode when we talk about some of the incentives and the way the industry is going. That's about it for all the time we've got for this episode. It's been really interesting. And if anybody wants to find out more about Discrete Heat, what's the web address?
DiscreteHeat.com.
Nice and easy.
Or Google ThermaSkirt or Google skirting board heating with a top result.
Fantastic. And there's plenty of stuff on there as well. YouTube videos and things like that. You said about and stuff.
If somebody's considering having ThermaSkirt in their house, we have a network of registered installers, a growing network of registered installers. So we are kind of reaching full UK coverage. And those registered installers, they also fit heat pumps, they fit boilers, they fit other products. And really, generally what happens is consumer comes to us and says, I want to get rid of my radiators. We put them in touch with the nearest installer. And it's basically a three-way relationship from there, really.
Straightforward enough.
Yeah.
Ethan, thank you very much.
Thank you. Thanks very much.